Good day, grade 10 students. Today what we're learning about is atomic structure. What that really means is we're learning about atoms, okay? And we're learning what atoms are made of. We're going to learn that it's made up of three things called protons, electrons, and neutrons. We're going to talk about what that means. We're going to relate it a little bit to the periodic table. So here we go. So on the periodic table, if you take a look, you'll remember that it's made up of elements. And when we talked about matter, which is anything that has mass and takes up space, we said it can be divided into a bunch of different things. And one of the things that can be divided into is pure substances. Now, pure substances can be made up of elements or compounds. And elements, basically what are elements? Elements are the smallest thing, most pure thing that we can have that cannot be broken down any further. But really when we talk about elements, we're talking about many atoms, okay? So element, when you say I have some elements, elemental gold, that means you have many atoms of gold as opposed to just one atom. Now, you can never pick up one atom, so it's so small, okay? If we wanted to count the amount of atoms that make you up, it would take the entire existence of time. It's incredible how many atoms make you up. Okay, so on the periodic table, we have all these different elements, and they're different because they're made up of different things. Well, they're all made up of protons, electrons, and neutrons. They just have different amounts of them. Okay, so we're going to talk about what that means. So every element or atom is made up of subatomic particles. Sub means to make atoms. So atoms are made up of subatomic particles. And they come in three flavors, okay? And those three flavors are protons. You write this down. This is important. You got to remember this. Electrons and neutrons. Okay? Protons are the most important subatomic particle. And the reason is it has something to do with their charge, but it has to do with some other reasons which we'll talk about in a second. Protons have a positive, because they start with a P, positive charge. Electrons have a negative charge. Now there's an attraction between positive and negative things. So protons really like electrons. They like to hang out together. Neutrons, on the other hand, are kind of strange. They have NEU. It starts with like neutral. They have no charge. So when we look at an atom, you'll notice that it has the positive charge in the middle. These are the protons. They're located in the nucleus. And the electrons are around the outside. And there is an attraction holding them together. They don't want to leave. So where's the location of these guys? Well, we know that in the center of an atom, you have the protons and the neutrons in something called a nucleus. So the nucleus is in the center. And along with the protons in that nucleus, you also have, I'll draw them solid. So you might have a whole bunch of protons in the center, and you might have some neutrons in the center. They are in the nucleus. Now this looks pretty big, but in reality, if this is the nucleus, it's actually very small. And the electrons, they spin around that nucleus. And the reason why they don't leave, they're going at the speed of light super fast. The reason why they don't leave is they have an attraction to those protons. So where are the electrons located? The electrons are located in something called shells or orbits. Okay? And that means that they are just flying around on the outside, and they have different orbits. There can be a whole bunch of different orbits that an electron can have. Okay, depending on the atom. Okay, and each orbit we're going to learn holds a different amount of electrons. Okay, so we've talked about charge, we've talked about location. Let's talk about mass. Now mass really means the amount of matter. This is going to be a weird definition. Okay, it's the amount of matter. It's really how much it weighs. Okay, you can think of it that way. And in the subatomic world, you can either weigh 1 or 0. Don't ask me why. It's just strange that way. Protons weigh 1 atomic mass unit. Don't worry about the AMU. They weigh 1. Electrons weigh 0. Neutrons weigh 1. Okay? So if we look at this atom right here, it's got 2 black ones here. Those are the neutrons. It's got 2 positive ones. Those are the protons. How much does this weigh? Well, it actually weighs 4 because it's got 4 things in the middle. And then you said, well, hey, sir, what about the electrons out here? Do they weigh anything? The answer is no, because they have a mass of 0. So why are the protons the most important subatomic particle? They're the most important subatomic particle because they both have charge, right there, there's my charge of +1, and they have a mass. Electrons, they have a charge, but they have no mass. Neutrons have no charge and no mass. So let's summarize this quickly again so you get this. Neutrons, large with no charge. Protons, large with a positive charge. Electrons, small with a negative charge. So atoms are made of 3 things. Neutrons, no charge, found in the nucleus. They have a mass of 1, we're going to say there. They're located in the nucleus. Protons have a positive charge, found in the nucleus, and they have a mass of 1 as well. And electrons have a negative charge. They orbit the nucleus. They're found in shells, and they have relatively no mass, okay, or 0 mass. Okay, so we say 0 AMU for that atomic mass unit. So why is it atomic mass unit? Atomic mass unit is like a kilogram or something like that, but it's a very, very, very light thing. Atoms are very, very small. There's the electrons on the outside. So in each orbit, only a certain number of electrons can be found. So if we have our tiny little nucleus there, what we have is we have electrons that are flying around it. Oops, let's back up there. So electrons are flying around. So we have a negative electron flying around that nucleus. It's very, very small. What's the charge in the nucleus? It's positive because of the protons. The electrons are negative. So in the first shell, it turns out that you can hold just 2 electrons. Okay, this little E negative means electron. And this is the first shell. You can hold 2 electrons right here. So that's my 1 electron. I can put 2 in there, and then it's full. Okay, the second shell can hold 8 electrons. Okay, and I'm going to show you where they are. So this is my next shell. Oh, that's ugly. 1, 2, 3, 4, 5, 6, 7, 8. The third shell, it can also hold 8. And that's all you need to remember. 2, 8, 8. So this is a memory thing. I would write this down. It's the most important thing that you got to know here. 2, 8, 8. Okay. So to find the mass, what we have to do is we have to add the protons plus the neutrons because they contain all the mass. So if I got 2 protons and 2 neutrons, how much do I weigh? The answer is 4. Okay, just add them together. Atoms are electrically neutral, so the number of protons equals the number of electrons. So if you got 4 positive protons, you will have 4 negative electrons. So we got to remember those 2 things. When we look at the periodic table, it's known as the atomic number, the small number on the periodic table. And it tells you how many protons are there. Okay, so if we look at the periodic table, I'll show you an atomic number, and it tells us how many protons there are. Each element on the periodic table has a smaller number. It's got a big number and a small number. The big number is located at the bottom here. It says 1.008. The small number is always a number without a decimal. So that's 1. So helium's number is 1. And as we go across, this becomes, sorry, that's hydrogen's number is 1. Helium's number is 2 over here. Lithium is 3. Beryllium is 4. Boron is 5. Carbon is 6. 7, and so on. 8, 9, 10. And then it starts off at 11, 12, and so on. And this small number tells you how many protons there are. This is known as the atomic number. And the atomic number equals the number of protons. Okay? So beryllium has 4 protons. Carbon has 6. Where are they located? In the nucleus. They have a positive charge. So if we zoom into helium, we can see it has an atomic number of 2. And the bigger number is known as the atomic mass. So the atomic number, we're going to find out it represents the number of protons. Okay? So if this is the number of protons, the atomic mass, which ones weighed something? It was the protons plus the neutrons. So if this weighs 4, okay, total, and you have 2 protons, the question is, how many neutrons do you have? Well, the answer is 2. One way to do this is if you just subtract these two numbers, you'll get how many neutrons it has. So it has 2 neutrons. My face is in the way here. Let's move me out of the way. So that the answer is going to be 2 neutrons. Okay? Now, how did the electrons equal the number of protons? Well, if you got 2 protons, you have a 2 positive charge. That's a positive. That also means you have a 2 negative charge. The protons will always equal the number of electrons. So by looking at these two numbers, the atomic number will be the protons and the electrons, the small number. Subtracting those two numbers will tell you the number of neutrons. Okay? So let's keep going. So in summary, atoms are made up of 3 things. They're made up of protons, electrons, and neutrons. Protons and neutrons are located in the center, okay? In the nucleus. Electrons are located on the outside. Protons have a positive charge. Electrons have a negative charge. If you want to find out the number of protons of any atom, you just look at the small number. For example, I'm going to look at silicon. It has a number of 14. That means it's got 14 pluses and it weighs 14 so far. To find the number of electrons, it's the same number, 14 negatives. Now, how much does this weigh so far if I have no neutrons? The answer is 14. Electrons have no mass. So if we look at the mass on the periodic table for silicon, it weighs 28.08. So I just rounded to 28. So if this weighs 28, and I know that that came from the protons and neutrons, I know that I have 14 protons. That must mean I have 14 neutrons. So in summary, you can tell how many protons and electrons and neutrons are just by looking at the periodic table. We'll practice a few.